Alright, hello. In this video, what I'm going to try to show is intervals of increase, intervals of decrease, max and min. Basically, how do you read this information from the graph? So let's see. Let me change the size of my brush. When I look at this graph, I automatically know that this is an odd degree function. How do I know this? Because if you look at the end behavior, this side is going, right side's going up to positive infinity, but the left side is going to negative infinity. So this tells you, because of the end behavior, that it's an odd degree function. So we're kind of going backwards. And it also tells you that the leading coefficient is positive because the right side is going up and the left side is going down. All right, let's see. Now, we don't really know what degree it is. Now, we can find the least degree, but we don't know if they're multiples of each other. So it could be 1, 2, 3, 4, 5. So the least degree that it can possibly have is degree 5. Why? Because it has 5 x-intercepts. Which ones are the x-intercepts? Well, they're right here. Color them in pink. It's where you're crossing the x-axis. So if we collect this information, the x-intercepts would be negative 3, 0, negative 2, 0, negative 1, 0, 0, 0, and 1, 0. And the next question that we can ask ourselves, well, what are the actual roots? Well, you have to remember that the roots are the actual x values. So in this case, it would be the negative 3, this negative 2, the negative 1, 0, and the 1. So if I were to ask you what are the roots, well, you would tell me that the roots are x equals negative 3, negative 2, negative 1, 0, and 1. Something else that I can ask you is what are the max and the mins? Well, the max and the mins is, in this case, is a relative max. This would be a max right here. And that would be the point that corresponds to the max. And the curve is going down. This is a minimum. We're interested in maximums. This is another relative maximum. Then it's going down, and there's no other relative maximums. So if I were to ask you for the maximums, you would say that the first maximum occurs at negative 2.644, 3.631, and that the other max occurs at negative 0.456, 1.419. And I could also ask you for the minimums. And you notice that the graph increases, and then this right here would be a minimum, and this over here would be a minimum. Oh, and I forgot to write what this one is, but we can kind of sort of estimate it. If this is negative 1 and this is negative 2, then this is probably negative 1.5 for the x value. And how far down did it go? This is negative 1, this is negative 2, so it's almost halfway, so let's just estimate it at negative 1.5. So it went over negative 1.5, it came down negative 1.5. And then, so that would be the relative minimum, and this would be the other relative minimum. So if I were to ask for the mins, you would report it as, well, one minimum occurs at negative 1.5, negative 1.5. And the other minimum occurs at 0.644 and negative 3.631. Something else that I can ask you for is intervals of increase. Well, where is the function increasing? Well, you remember for the increase, we talk about from left to right. So the function is here at the utmost left, right? And all of this, it is increasing. And where does it stop increasing? Over here. Let me change colors because this yellow is not working. All right, so the function is increasing, 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 right? So we look at the x values for the intervals of increase. So we focus on the x values. So it stops at this x value, but where did it start? Well, it started at negative infinity. So from negative infinity, when x was negative infinity, up until x was negative 2.644, the function was increase. Forgot the 6, didn't I? Okay. And then the function was decreasing. But at this x value, the function started increasing, right? And it stopped at that x value. So from negative 1.5 until x was negative 0.456, the function was increasing again. Then over here, the function is decreasing, but at this x value, the function starts increasing again, and it goes all the way until x is positive infinity. So the next interval of increase starts at 0, I think it's positive 0.644, because it's the x value, all the way to positive infinity. So those would be your intervals of increase. So where is the function decreasing? Well, the function is decreasing. It's increasing over here, but at this point we have a transition. So from this point, function's going down all the way up to this x value again. So intervals of decrease. Once again, you're going to focus on the x values. So from negative 2.644 until negative 1.5, the function is decreasing. Then the function starts increasing, and once again, at this x value, the function starts decreasing all the way up to this x value again. So from negative 0.456 all the way up until x is 0.644, function decreases. And the function never decreases again, because once it starts increasing, it increases for x being infinity. So these would be your intervals of decrease. Something else that I can ask you is for your domain. Now the domain changes depending on whether you are odd or even, and this one happens to be odd, so your domain is all reals. Now if it was even, it would be a different story. Did I just say that completely wrong? Scratch what I just said. Domain is always all reals. Scratch what I just said right now. Domain is always all reals. It's the range that matters, whether you're odd or even. And this one happens to be odd, so your range is all reals. Okay?